Laser up, laser up. Okay, you turn this side. This is a single mirror. You see a mirror?
Yes.
So the mirror size is about 700 millimeter. This much. And there is a center hole. What is the purpose of center hole? I will tell you. There is a center hole in the mirror. The mirror front surface looks like white because its coating is given.
Yes.
Aluminium coating, because it has to reflect the light. Otherwise, it will not reflect the light. And moreover, the important point is it has a curvature. It has got a curvature. The mirror which we are putting in our bathroom to see our face, it is what kind of mirror it is? Plain. It's a plain mirror. There is no curvature. That's the difference between that and this. That mirror has backside coating, not front side coating.
Okay.
Coating is there in the backside.
Backside.
This fellow has front side coating.
Okay.
This has a front side coating. Correct? There is a hole, there is a curvature, that's a dimension, there is a coating. That's all. That's all about the mirror. Now, how this mirror is behaving, we will see. Let's on now. See here, this is the light ray which is coming, something similar to the light ray coming from the celestial object, the sky. The light is coming here, hitting the primary mirror. There's a big mirror is called the primary mirror. Primary means one, the first mirror. And then the mirror is reflecting the light. The reflected light is coming to a point here. You see here, this is a reflected beam.
Yes.
That beam is coming to a single point. That point is called focus. That is a focal point. This plane is called focal plane. Name of the focal plane is called prime focus.
Yes.
Because the primary focus is formed by the primary mirror. That's why it is called prime focus. We have got one focus now.
Yeah.
If I put my camera here, I can register all the celestial objects.
Okay.
Whatever is reflecting the light.
Whatever it is reflecting by the telescope, that can be captured here.
Okay.
Got it?
Yes.
So that is a basic principle of single mirror telescope. Don't touch anything.
Okay.
Move that side.
What is this? In the side of that circle, the primary mirror make a difference to the focal point?
I'll come to that. All questions I will answer. Keep questions with you now. Right. So that is a single mirror telescope focus is called prime focus because the mirror is a primary mirror. Correct?
Yes.
Now we will go to the second focus. Next focus. What I am going to do, I am going to introduce my second mirror. It's called secondary mirror. I am putting secondary mirror. Now it is put now. Now you see here, same beam goes here, comes to the secondary. You see here now?
Yes.
And then secondary is reflecting the light which is coming here. You see?
Yes, sir.
This is the beam which goes to this mirror, comes to the focus there. That means now the focal length is increased now.
Yes.
The beam is coming all the way from there, coming to the secondary, going to the third mirror, then it is coming there. Correct?
Yes.
The travel is too much. That means the focal length is larger. Focal length is larger now compared to this. Correct?
Okay.
So now this focus is formed by three mirror. Primary mirror, secondary mirror and the tertiary mirror. All the mirrors. That means the focus is called three mirror focus or it is called Nasmyth focus. There is a separate name for Nasmyth focus. Yes, Nasmyth focus there. Correct? Now, I have not explained about the secondary focus because that is a three mirror focus, right? Suppose if I remove, I am not going to remove because it will take a lot of time. So if I remove this mirror from there, suppose if I remove that mirror, what will happen to the focus? Where the focus will go?
That goes.
It will go through the hole, it will come backside the mirror, behind the mirror. Correct?
Correct.
This is how we can take three forces we can get from this three mirror telescope. Correct? So three can be applied. Now lights off. Okay, now questions. Don't touch this again. Little move backside. Alright, okay.
So what is the upside of having a larger focal length? This thing, increasing the focal length?
Let him explain, sir.
Wait.
Please.
I'm going to explain for the questions one.
Yes.
Okay.
What is the benefit of increasing the focal length? Like we are trying by multiple mirrors, right, to increase the focal
Number one. Question. Next. Any other question? The question is that what is the significance of longer focal length? I said this is a shorter focal length. If you measure the length, it is shorter. But that focal length is very longer.
Very long. Yes.
Compared to this, it is 3 times or 4 times longer. Question is that what is the significance of long focal length? Any other question?
What is the size of the mirror?
Come to the point. How this mirror size becomes, or is there a relationship to the image? That also I will give you. Anything else?
What will happen to the image when it goes behind the...
Exactly, I'll tell you that. Anything else?
There are Dobsonian is like two mirrors, right?
Yes.
It's like the one in which we remove that.
Right, okay. Maybe I can just answer now one by one. Dobsonian is basically, what is the difference between Dobsonian telescope and this telescope? Because there are display there in the Dobsonian telescope displays also there. You can go to the stall and see. There, the primary mirror is same, which will come to the focus here. Just before the focus, you have a flat mirror, like that mirror. Just a flat mirror, it will take the focus outside. That is Dobsonian. This is not Dobsonian. That is Dobsonian. Correct? Now, in this mirror, in this configuration, that is a curved mirror. This is also a curved mirror. But that's a flat mirror. Correct? Your question is answered? Now, coming to the longer focal length. Now, so listen to me carefully now. The shorter focal length versus the longer focal length. Shorter focal lengths will collect the light and focus it very sharply. Sharpness is more here. Longer focal length will magnify the image, blow up the image. That means the same image, if I record there, it will become big in size. If you want to see inside the image, if you want to see any feature, you have to blow it up. That's why the longer focal length.
Or I can say it in this way also, it helps to capture, see things very distant.
Not like that.
Not
No,
like that. Okay.
not like that. Distance doesn't matter here.
Okay.
So, when you blow up the image, you can see the features in that. You got the point? So, magnification is important.
Zoom
Yeah,
basically.
Zooming, yes.
Yes.
So, optical zooming, not digital zooming. Optical zooming. So, basically, longer focal length is equivalent to zooming the image so that you can see the minute features that are important. Those minute features are important for doing science. Got the point? Right? Shorter focus and longer focus I have explained. I will come to your question. Any other question? Now the question.
What if you put the same exact mirror on the opposite side?
Which mirror?
Like same exact mirror and you put it on the opposite side, what will happen to the
Nothing will happen. We put the source that side then.
Oh, okay.
This source we put that side.
Oh,
Correct? Nothing will happen.
big questions.
Okay, now you asked a question about the size of the mirror. Now, I'll tell you that size. Before coming to the size, I'll just give a small example. See, night time you are going outside. Look at the night sky. Look at the night sky. There's no moon, dark sky, but you are seeing the bright objects, stars. Nowadays you can see those planets also. Forget about the planet. See those stars. What is the faintest object? What is the faintest object we are able to see through our naked eye? We cannot see all the faint objects. Fainter object I cannot see. Bright ones only we can see through our naked eye. Why?
Light photons coming.
Amount of photon, the light which is coming from those faint objects are not sufficient to detected by our eye, because our eye size is very small. A typical eye size is about 5 millimeter. The lens size is only 5 millimeter. Correct? That's why we are not able to see the faint object. We can see only the bright objects. Now, suppose your telescope you are going. Telescope is nothing but a light collecting bucket. Light collecting bucket. Bigger the size, larger the light. Bigger the size, larger the light you are collecting. Large number of photons you are collecting. Now size is more and more, you are collecting more and more light. You can see fainter and fainter and fainter an object you can see. That's why. See nowadays people are making a very big telescope, 30 meter telescope, 40 meter telescopes are coming. Why? Because people want to see the fainter and fainter and fainter an object. They are far and far and far and far away from our vicinity. Right? That's why they are going for the bigger telescope. Right? That makes sense? That's why size becomes more efficiency.
By putting 3 mirrors, we are saying we are increasing the zoom and all everything.
That's right.
So if we increase, how much many more mirror we can add so that we can get every other minute particle of that celestial body and everything? Is there any limit, or we can just increase the
It is not the question of number of objects, it is a question of
number of mirrors?
Mirrors.
if you keep on adding, two effects are there. If you keep on adding the mirror, which is going to increase the focal length, 1 meter become 10 meter, 10 meter become 100 meter, let us say, no problem. Magnification proportionally increases, linearly increases. but at the same time, one mirror to the next mirror when it comes. The one mirror reflection is only 90%. 10% is lost. Second mirror is 90 of 90. Only effect is 80%.
81, yeah.
Next mirror, 90 of 80, 70% gone. Next mirror, 90 of 70, 60% gone. Finally, you will get only 10% if you give number of mirrors.
Okay.
So efficiency will drop. But even then, such kind of telescopes are available. If you go to that glass building, you will see there is a telescope called National Large Solar Telescope where n number of mirrors are there. But that is meant for studying what actually? Sun. Sun gives a lot of energy. You don't have to worry about anything. You can put n number of mirrors. Still you will get sufficient amount of light.
Wow.
So
That's it.
One question regarding that. So if I increase the number of times of mirror reflecting and so what I'm doing, I'm increasing the magnification. But every time there is some attenuation happening of the number of photons on this thing.
Correct.
So this is that event of this thing is a random thing in nature.
Systematic. It's not random. It's very systematic.
Very systematic.
Yes.
So if it is systematic, then it can be corrections can be done by filters and all, right?
No. If you are, once the photon is lost, then how do you get it back?
Yeah, correct. But if
No, if
I-
any error comes, then you can correct it.
Correct it.
If there is some error which is coming, error contribution, if it is systematic, it can be corrected. But photon lost is lost.
So, I mean,
Lost is lost. You
so
can't do it.
the way it is losing it, that is random. That is what I thought. Like when
Way
you-
to?
Is that a random thing?
No, it's not
It's
random.
not.
Very
So I was thinking that
systematic.
If I oversample it and if I multiple samples, then it can get better and better.
No,
This image.
no. That is basically, I will tell you that you are talking about when the signal becomes poor and poor. Instead of taking one frame, you put n number of frames and co-add them and get the signal. That is different case. That's totally different. Your signal becomes poor, but you are spending a lot of time then. I want exposure. I want to take a telescope for exposure. Let us say 10 minutes. Then if a signal is weak, I will just go for 1 hour exposure. I am losing time.
Yeah.
Correct? That's not the right way to do.
And that 10% loss you said, right? That
Yes.
depends on the coating and the.
Purely depends on coating.
Okay. So that's the maximum efficiency you can get.
I said 90%. That's the max.
Maximum you can get.
Yes.
You can't go.
Metal layer cannot give anything better than that. 90%.
So
And that's
what
the
layer
fo-
can give us a better efficiency?
So metal can, when it comes to the metal layer, aluminium gives the best. Aluminium gives the best reflectivity in the shorter wavelength, like UV wavelength and blue wavelength. Silver is another material. Silver gives a good reflectivity in the IR range, red and IR. Right? That's why the IR telescopes are made with the silver mirror.
So depending on what wavelength you want to capture, they can have a different kind of coating.
Exactly. Yes.
Is that what you focus here?
Yes, very much.
Area of focus.
Yes. Our area of focus is only on the optical band, not IR, not the infrared.
It's mostly.
Mostly, that's why we are using aluminium. Go to the next experiment.